If there's one video that can most help you to transform your thinking about linear algebra, it's this one. We've seen, practically speaking, how to think about a linear system of equations as being a matrix vector equation. Matrix times vector equals known vector. And think about how do we solve that equation to discover the value of x. What we haven't seen yet is a picture that can help us to understand what's happening in this equation from a transformational viewpoint. What I mean by that is we want to understand how a matrix transforms one vector into another vector. And that's the viewpoint we're going to take in this short video. The key insight, and one that we will later on elevate to the level of what we'll call the fundamental theorem of algebra, is that we can and should think about a matrix like it's a function. And as with any function, it takes in an input and it produces a unique output for every input. And the way that a matrix defines a function is by multiplying its input, which is a vector, on the left to produce the output. So here, the key mental shift is that we're thinking about this unknown vector, this x vector here, as an element of the domain of a function, and this output vector, my b in my matrix vector equation, as an element in the codomain of that function. Here's the input, here's the output. And so solving this matrix vector equation is really about asking the question, what input do I put into this function which will produce the output, negative 2,8? And that becomes a transformational viewpoint. And the picture that's ever in my mind's eye when I think about linear algebra is a picture similar to the one we see here. On the left is a copy of the xy plane, R2, if you like. I'm going to think of that as the domain of this function. On the right is a copy of R2, again the xy plane. I'm thinking of this copy as the codomain. So here are where all of my outputs to this function live. Here's where all my inputs live. Or put another way, here's where all of my x's live. Here's where all of my b's live. And the matrix A is the connection between these two realms. In other words, the matrix A, by multiplying that vector on the left, takes a vector from my domain and produces for me a vector in the codomain. In our last video, we saw that this particular system has a solution, xy equals 4, 2. In this transformational viewpoint, that means that if I take the vector 4, 2 here in my domain, if I take that x vector, and I multiply that x vector by my matrix A on the left, the result is going to be the vector negative 2, 8, my b vector, living here in the codomain. And the key to this understanding is that the matrix is not an element in the codomain or in the domain. The matrix is not one of these vectors or another. The matrix describes the connection between domain and codomain. The matrix is the function that relates domain to range. So that if I change my input vector to something else, then the output vector that I get is also going to probably change. So if I pick a new input vector, like let's say 1, 0, if I multiply this matrix by 1, 0, I'm going to get the vector minus 2, 1 in the range. Now that vector just happens to be the first column of the matrix A. And by the same token, if I take this particular input vector, 0, 1, and I multiply this matrix times that vector, then the vector that I get in the codomain is going to be the second column. But any other vector that I choose in my domain is going to give me possibly something else, some other vector in my range, and all of those vectors are linear combinations of those two columns. And the weights of those linear combinations are exactly given by the entries in that vector. So for example, if I take the vector 1, 2 in the domain, I multiply by the matrix A, I'm going to get a vector in the range which is one copy of the first column added to two copies of the second column vector. In this case, that gives me 4, 5. And so to solve any linear system of equations of this form, ax equals b, all I'm really doing is I'm selecting a b in my range and asking what vector in the domain has as its image this vector b. And the matrix provides the connection between these two worlds that makes linear algebra run. And all the questions about whether or not this equation has a solution at all, Or if it has a solution, how many solutions does it have? All of those can be explained by this transformational viewpoint in a variety of ways. This is my mental picture anytime I think about linear algebra. And I think if you sit with it for a while, it'll really become your friend, both in thinking computationally and also conceptually about the ideas of linear algebra as the subject goes forward. And if you want to play with this app, it's really a lot of fun. You can find a link to it through my website, which is listed right here, mathematics.com/OLA. Happy hunting.